Hey everybody, welcome to another video. So today we're going to work with the subdiv object, which is a new object that came out with Max 8.3, much like some of the others that we've been working with, and we're going to use that to produce sequences based on probability. Let's get into it. So as usual, we're going to start with a phasor, and we're going to start with a transport. And we're going to create a live.scope so that we can see that phasor. And there it is. And then we're going to create a subdiv. And we'll give it the argument 8. And what subdiv does is very simple. It takes an input phasor and it breaks it up into many smaller phasors. So we're getting 8 ramps from 0 to 1 for every 1 ramp that this parent phasor produces. And subdiv has, in addition to this div attribute, it also has one called prob, which is a probability. So if I set that probability to 0.5, then half of these subdivided phasors are actually going to be output. And like I'm doing here, I can either use a single value or I can actually create a list of values. So I could say 1, 1, 0, 0.5, and 0. And you'll see that now we're going to always get 2 in a row. And then sometimes we'll get a third and then a gap. And you can tell that you can see that the object's actually pretty smart. I have a list here that's only 4 items, but it's automatically wrapping that around for me. So this is a pretty useful way just right off the bat to create interesting patterns. Another thing that we could do is create a matrix control with just 1 row and 8 columns so that it's 8 steps. And you've seen me do this in the past. We'll say get row 0 and we'll collect that to the left outlet, and then we'll connect the output of that message box into the left inlet and connect that to the prob control. And now we are basically setting probabilities of 0 and 1, which allow us to create a step sequence. So there was another way that we did this in a prior video with the what tilde object. And this is another way to do the same thing. We still are going to want to turn each of those phases into a little impulse that looks like this. Because eventually we're going to want to add up these impulses to have sort of a counter of the number of steps that have passed. And if I connect that what tilde object to subdiv, you can see I'm getting a bunch of pulses. And there's a few attributes of what tilde that we need to configure in order to get it to work correctly. Because the output of subdiv will produce some phasors that are not immediately followed by another phasor, we'll get these situations where actually what tilde produces an impulse at the beginning of the ramp and at the end of the ramp. So what we need to do is tell what tilde that its trigger mode should be ascending. So basically now it's going to look for the value 0, which is the default value for this matches attribute. And it's only going to trigger an impulse when the value is rising past 0. And actually I noticed that this, even with these settings, the object doesn't exactly do what I would have expected, which is that I would have expected to get an impulse at the very beginning of the upslope of this ramp. We actually get one, like if I just make a really simple sequence, we actually get one at the beginning of the and the end. If I create another one of these just for demonstration purposes, and I say that the trigger mode should be 1, so descending, you're seeing I'm actually getting an impulse at the end of the ramp. What I want is a single trigger at the beginning of the ramp. And the way to do that, the only way that I've found, which is a little bit ugly, but works, is to set this matches value to some value that's very low, but is not 0. And if I compare this output to a trigger mode ascending where the matches value is the standard 0, like this one, you can see we're getting that first impulse at the correct time, but we're not getting the second one. I submitted this actually as a sort of a question to Cycling 74 because it seems to me like matches 0 ascending should work like this, but it doesn't. But this works well. Okay. And so then we can simply add up those pulses. And we have this running count now of the number of pulses that have occurred. And now, if you've watched the other videos, you've sort of seen this process happen where we produce a pattern with a bunch of pulses, we count those pulses, and then we have some mechanism. In the past, it's been the stash object that stores values that might be things like MIDI notes or velocities, and then the counter is able to look up those values. So we could do that. We're going to do basically the same thing with a slightly different method using one of the other new 8.3 objects, which is called table tilde. So table tilde is a relative of the table and itable objects that are that have been around in Max for a long time. And the way that they basically work is that they create a table with a bunch of columns and rows, and for each column there can be one value that indicates the row, and we can pass in a row value and get out the corresponding column, or other way around, we can pass in the column number and get out the corresponding row value. I'll show you that in practice, and it'll make a little more sense. So the first thing I need to do is give the table a name, and then the second thing that I need to do is tell it to what to do when the value, actually I'll give it a size next, sorry. Size is going to be, let's say, 7. And then I'm going to give it this extend attribute, which is going to tell it what to do if the value that it receives is more than 7 or less than 0. And the default is, I think it's 2, which is wrap. So if we get a value of, say, 8, it's just going to wrap around to 0. I'm sorry, if we get a value of 7, it will wrap around to 0 because it's going to count 0, 1, 2, 3, 4, 5, 6, and we'll show that in action. And we also need to do output scale. So we're just going to say that we want the values that are output to be, say, between 0 and 24. And now if I create an itable object with the name notes, I'm actually, with this little user interface, I'm setting those values. And so now if I pass in the counter, and actually to even start, why don't we just start passing values to make sure that it's working as we expect. So if I say 0, then I should get 71. That looks correct. If I say 6, then I get 89. So we're 6 over here, 89. So that's working correctly. And if I say 7, I should get 71 here, right? So the first value. So that works great. And it looks like the output scale is not doing what I expected it to do. let's see what happens if I say range 24. And now okay, so I thought the output scale would basically just take the internal value of it and scale it to the range that I'd specified there. It didn't, but we can easily solve that problem by just making the range some value between 0 and 24, which is basically 2 octaves. And then we can add a little offset in so that we can actually get that number to be in a range where those MIDI notes are not super low pitches. So I'll just create an integer box, multiply that value by 12, and then add that to the output. So if I say 3 here, then we're going to be in that octave range from, let's see, it's like 36 to 40, to 6 to 59, I guess. Okay. So now we basically are almost all the way to having a sequencer. The last thing that we have to do is something that we've done in the past, which is just convert this value from a floating point, or rather from a signal, into a floating point number so that we can send the value out over MIDI. And in the future, actually, I think probably in the next video, we're going to start to talk about some techniques about how you could actually generate sounds inside of Max without having to send MIDI out. In this case, I'm actually just sending MIDI to Ableton Live. So we're going to take this make node object and connect the output of the snapshot to that. And in order to get the snapshot to convert the signal to a float, we can tell it exactly when we want it to do that by banging it. And we can trigger that bang when the what object outputs something. So now what's happening is that it's just walking through this sequence that we have here. And something that we could do that might be fun and interesting is create a little viewer so that we can actually see the sequence as it walks along. So let me do that. So I'm just going to create another matrix control. I'm going to say ignore click, and I'm going to say one row. And then I'm going to make another subdiv that has no probability. And where is that object? There it is. It's always annoying having invisible objects. I'm just going to connect it to something so I can see it. And then, so the subdiv does a nice thing of, from its right outlet, it's going to output its step number as an integer. And because we have this one row option enabled for matrix control, anytime we activate one of the buttons, it deactivates any others in that row that might be active, which allows us to have this step counter. And this syntax is simply, we're just saying, set the button at the position of whatever row, whatever column, row 0, turn it on. And when we do that, it will turn off any others in the row that are on because of that one row feature setting. So if we now line this up, we actually have a nice kind of little viewer, and we can even just plop another one of these down here so we can see what's going on. Could even I wonder if there's a way to make these square. Let's find out. Don't think there is. So perhaps not the prettiest approach, but it works. Do it like that. Okay. Cool. And if we make the pattern more elaborate. Great. So right now we're using probabilities, but we're kind of just using them in a really simple way, which is just to create oscillating between the probability of 1 and 0. And of course we could go back to, using just a single number and having like a totally random pattern, or of course we could go back to kind of inputting these values, which is fine. But I think that one thing that's kind of interesting and a cool way to do things is actually to have a second one of these. So we'll have a pattern. We'll create a pattern with this. And then we'll have another one of these. And then we'll use maybe a multi-slider. With 8 sliders in a range of 0 to 1. And then we'll use that to set the probabilities for this other one. And then we'll ask whether that output of subdiv is greater than 1. And the result is going to look like this kind of castle pattern. So now basically we have the same thing happening with subdiv producing, according to these probabilities, the ramps. Like if I connect the scope to the output of subdiv, you can see these ramps, but by saying, well, if it's greater than 1, just give me 1. Or sorry, greater than 0, just give me 1. And then what that allows us to do is multiply together the output of our original subdiv and this other one. And then we can do things like this. So if I have a sequence, I can be like, oh, and if I line these up really nicely, you know, play this middle one in this set of 3 only half the time. And if you ever use like an Elektron Octatrack or any of the gear from that company, this is something they support. So you can, you know, create a sequence with a bunch of steps, and then for any one of those sequence steps, you can specify a proportion for how often that, or what the likelihood that event should actually fire is. And I know this isn't like terribly musically interesting, but I hope you can imagine what the, you know, for demonstration purposes, what the possibilities of this are. Okay, so let's clean up just a little bit here. So this we'll put over here, and this we'll tuck over here. So I think the only other thing I'm going to do at this point is just create another one of these tables for velocity, and then we'll be done. So I'm just going to duplicate this. I'm going to name it velocities. I'll set its size to, I don't know, let's say 9. And a range will be 127. And then we'll just do the same snapshot thing. And we need to change actually the name of this to velocities as well. There we go. I'll just cancel this for it. So yeah, the way that the relationship between these table tilde objects and this iTable object work is that they just refer to the same underlying data with the name. You can also edit these by just double clicking the table object like that. But I like to have it in the patcher like this. And then there is actually one more thing that I wanted to do. So at this phase here, let me move some things a little bit. Right here, you can see we're counting, and we're actually just counting up forever. Right. And we don't need to worry about the fact that it just counts up and up and up and up because of this really convenient extend to attribute that we have on the tables. This is something that Stash doesn't have, so we had to have mechanisms in place when we were using that approach to make sure that the output of the counter stayed within the range that the object was expecting. But table makes it pretty easy for us. But what would be really cool would be to make it possible to kind of jump back to the beginning of the melody. So the way that we can do that is with a bang and a click. And I'm actually just going to slap a gate into the output of our notes snapshot so that we can just keep the sequencer running but not hear the sound. And if I open this gate and I have a sequence, you can hear it, right? And if I bang with this click, the right inlet of this plus equals tilde, you can see it goes back to 0. And the click is just an impulse, right? Now, this works, but there's one issue, which is that that reset is not going to be synchronized with the pulses that come out of what. So if I have, 8th notes or 16th notes, like I'm probably not going to click accurately enough to actually have that be in time, and I'm going to have this weird event that's out of sync with the others. So what we kind of want to do is actually create like a kind of signal version of one bang. So one bang is an object, a max object, that will take a bang from into its first and second inlets, and it's not going to output anything until the right inlet is banged. And then when I bang the left one, it'll output something. And so we kind of want the same thing here. We want it to be so that it's not until this one is banged, or rather this impulse flows, that an impulse from the what tilde object will actually reach this plus equals tilde. And there's probably a few ways to do this. The easiest way that I can think of is to use gen. And I'll show you. So we'll connect everything like this. I'll get rid of one bang. And I'll come in here, and the first thing we'll do is create a saw, which stands for sample and hold. And basically, the way that works is it can receive a signal into its left inlet. And by the way, because we're inside of gen, we don't use the tildes, and we get these gray patch chords. But just remember that we're working with signals the same as these dotted patch chords here. A signal is passed into the left inlet, and anytime it receives an impulse into the right inlet, it basically outputs the value it's currently receiving at its left inlet. So if I send an impulse and I send it to both of the inlets, it's going to basically, and the impulse goes from 0 to 1, it's going to just send out 1, which is convenient because then we can pass that into the control input of a gate, and then we can pass the impulse that's coming from what. So let me annotate this here. Is this first output, and then this is going to be the click. And then when we get from what its next impulse, what we can do is use the history object, which will allow us to feed that signal back into the trigger input of saw. And at this point, presuming that somebody is not also clicking at the exact same time that this impulse comes from what, then the value currently being received at the left inlet of saw will be 0. So it will output 0 and close the gate which will make it so that no other impulses from what flow through. So let's test it. So let's make a really simple pattern. And we're watching this thing go along. And I'm going to click it somewhere over here. And my expectation is that the number will only reset when it comes back to the beginning. And I'll put this over here so we can actually see. All right, let's do it. And I'll put the bang over here too. Cool. Ready? I'm going to click, and then it's not until it actually gets there that it resets. So that totally worked. If we had more of these, of course, it would happen whenever the next one occurs. So that's pretty cool. And that's kind of a fun, so like, let's actually hear that. Oops, I zoomed in a ton. So anytime I bang this, I'm going to go back to the beginning of the melody. So you can hear anytime I click here, very often I'm clicking after this lowest note, so we're not getting these higher ones. If I really make this obvious, you can hear we're going back to these middle pitch notes. Cool. So that's basically it. I'm gonna clean this up, share it as usual. Next time, I think we will talk about some pretty cool ways to actually cut all this MIDI business out, including the snapshot, and actually trigger sounds within Max using plugins. So we have there's an object called VST tilde and another object called MC.MIDI player, which is yet another one of these new Max 8.3 devices that allows us to trigger notes in those VSTs with signals. So we never have to do any snapshotting, and we never have to work with events, which is pretty cool. Cool. Thanks so much. Happy patching.